Hi students, I welcome you all for this lecture video titled Basics of Contour Integration. In this video we are going to see few basic definition involved in contour integration. Also we are going to see some of its applications. Contour integration, it is a powerful tool in solving many real life problems. Contour integration, it involves evaluating integrals of complex functions along path. Here path is called contour. So let us see a few basic definitions. First one is complex number. I hope many of you are known with this term. A complex number can be written as a plus ib, where a and b are real values, where a is called real part and b is called imaginary part. So we can plot the complex number like this. On the x-axis we can mark the real part, and on the y-axis we can mark the imaginary part. So here z equal to a plus ib is a representation of a complex number. So next, complex functions. So complex function is very similar to our real valued function. So in complex function it maps a complex variable in z plane to another complex variable in w plane. You just look at here. Here the point z is mapped onto the point w. Okay. Next we'll see what do you mean by contour. So contour, it is a certain curve. So it is a certain curve on which we define the contour integration. So contour integration is a piecewise smooth arc. Mathematically speaking, it is a piecewise smooth arc. So it is a differentiable arc and having non-zero derivative. That means the curve is a differentiable, at the same time the derivative is not zero. So next definition is a piecewise smooth curve. So just look at this curve. So the curve is divided into different segments, C1, C2, C3, C4 and C5. So on each and every segment the curve is continuous and differentiable. So this such type of curves are called smooth, piecewise smooth curves. Just look at these pictures. We are surrounded by beautiful contour patterns. Just in this picture you can observe such contours. So next, look at the applications of contour integration. The first one comes in electrical engineering. Suppose consider a problem of finding the response of an electric circuit to a sinusoidal input signal. So this can be done using the complex integration. So here the response can be calculated using the contour integration. That is, here the formulae h of t equal to 1 by 2 pi j integral over gamma h of s e power st ds. So this is used to calculate the response. Here h of t is called the response and h of s is called the transfer function. So here gamma is the contour which is used to evaluate the integration. So next application is aerodynamics. You just consider here modeling an aircraft. Here the study of airflow around the wings of the aircraft can be studied using the contour integration. In the similar way, considering the construction of a car. So here the drag and lift force can be calculated using the contour integration. Here just see the drag function is a vertical function, horizontal function, and the lift function is the vertical function, vertical force. And in the fluid dynamics, contour integration is used to observe the particles or the fluid behavior around an object. Next one is in quantum mechanics. So in quantum mechanics, transition amplitude, that is a complex number that quantifies the probability of a system transitioning from one state to another. So this is also done using the complex integration. Next, the particles interaction can also be analyzed, and the particles wave function is also calculated making use of the contour integration. So the last one is the mathematical financing. So no one can exactly say the cost of a commodity at the end of the day, but we can predict the value. So mathematical contour integration is used in predicting the price of the commodity. So I hope you all understood the concept well. Thank you for watching the video.